Pro Football player Travis Kelce is pressed for time during the football season. So he does two things at once. Whether it's grilling while mowing.
Two things at once!
Or getting this season's updated COVID-19 shot at the same visit as his flu shot.
Two things at once.
You can be like Travis and ask your pharmacist about getting this season's COVID-19 shot at the same visit as your flu shot, if you're due for both, as recommended by the CDC. Learn more and schedule at vaxassist.com. Sponsored by Pfizer.
Well, shopping for a car?
Yep, Carvana made financing a car as smooth as can be.
Oh, yeah?
I got pre-qualified instantly and had real terms personalized just for me.
Doesn't get much smoother than that.
Well, I got to browse thousands of car options on Carvana, all within my budget.
Doesn't get much smoother than that.
It does. I actually wanted a car that seemed out of my range, but I was able to add a cosigner and found my dream car.
It doesn't get much...
Oh, it gets smoother. It's getting delivered tomorrow.
Visit Carvana.com or download the app to get pre-qualified today.
Good day, everybody, and welcome to the Astronomy Daily podcast for Friday, the 27th of October, 2023. Astronomy Daily, the podcast. My name is Tim Gibbs, and I will be your host for today's episode. I also have here in the studio with me, Hallie, my AI assistant. But before we go over to Hallie, a quick and shameless plug. Don't forget, everybody, that you can get all of our current, past and future episodes at spacenuts.io and bytes.com, with a show from Steve on Mondays from New South Wales Down Under, and from myself here in the beautiful city of Bath in Somerset. You can also get our parent podcast, Space Nuts, with Professor Fred Watson and Andrew Dunkley. You can also sign up for our daily newsletter via email, the Astronomy Daily newsletter. This has lots and lots of stories handpicked by the team here at Astronomy Daily, including Hallie. You can also join in the conversation with our Facebook page, Space Nuts Podcast Group. We would all love to hear your views and welcome any feedback that you want to provide. Now, over to you, Hallie, for our stories of the week.
Hi, Tim. Great to be back with you. Here are my stories of the week. NASA's Illumity payload is set to launch to the ISS, aiming to demonstrate the potential of laser communications for faster data transmission. This collaboration with LCRD could revolutionize how data is relayed from space, offering rapid transfer rates. NASA is demonstrating laser communications on multiple missions, showcasing the benefits infrared light can have for science and exploration missions, transmitting terabytes of important data. The International Space Station, ISS, is getting a flashy technology demonstration this November. The Illumity Integrated Laser Communications Relay Demonstration Low Earth Orbit User Modem and Amplifier Terminal payload is launching to the International Space Station to demonstrate how missions in low Earth orbit can benefit from laser communications. Laser communications uses invisible infrared light to send and receive information at higher data rates, providing spacecraft with the capability to send more data back to Earth in a single transmission and expediting discoveries for researchers. Managed by NASA's Space Communications and Navigation (SCAN) program, Illumity is completing NASA's first bidirectional, end-to-end laser communications relay by working with the agency's LCRD, Laser Communications Relay Demonstration. LCRD launched in December 2021 and is currently demonstrating the benefits of laser communications from geosynchronous orbit by transmitting data between two ground stations on Earth in a series of experiments. Some of LCRD's experiments include studying atmospheric impact on laser signals, confirming LCRD's ability to work with multiple users, testing network capabilities like delay/disruption-tolerant networking, DTN, over laser links, and investigating improved navigation capabilities. Once Illumity is installed on the space station's exterior, the payload will complete NASA's first in-space demonstration of two-way laser relay capabilities. Illumity's optical module is comprised of a telescope and two-axis gimbal, which allows pointing and tracking of LCRD in geosynchronous orbit. The optical module is about the size of a microwave and the payload itself is comparable to a standard refrigerator. Illumity will relay data from the space station to LCRD at 1.2 gigabits per second, then LCRD will send the data down to optical ground stations in California or Hawaii. Once the data reaches these ground stations, it will be sent to the LCRD Mission Operations Center located at NASA's White Sands Complex in Las Cruces, New Mexico. After this, the data will be sent to the Illumity ground operations teams at the agency's Goddard Space Flight Center in Greenbelt, Maryland. Their engineers will determine if the data sent through this end-to-end relay process is accurate and of high quality. A recent study published in Nature investigates recent observations from NASA's James Webb Space Telescope, JWST, and ground-based telescopes of heavy elements within the ejected material of a recent gamma-ray burst, GRB, classified as GRB 230307A, that was likely produced by a kilonova, with GRB 230307A being designated as the second brightest GRB ever detected. The heavy element in question is the chemical element tellurium, which is classified as a metalloid on the periodic table. However, scientists also hypothesized that the element iodine, which is a requirement for most of life on the Earth and classified as a reactive nonmetal, could also exist within the kilonova's explosion, with both elements residing side by side on the periodic table. Just over 150 years since Dmitry Mendeleev wrote down the periodic table of elements, we are now finally in a position to start filling in those last blanks of understanding where everything was made, thanks to Webb, said Dr. Andrew Levon, who is a professor of astrophysics at the Radboud University in the Netherlands and an honorary professor at the University of Warwick in the United Kingdom, and lead author of the study. Tellurium is one of the rarest elements on Earth, even rarer than platinum, and is used for a variety of metal alloy applications, including semiconductors, oil refining, and solar cells, just to name a few. While rare on Earth, tellurium has been detected in planetary nebulae and ancient stars. The other element detected with these recent observations, iodine, is a requirement for life on the Earth, as it has been found to help alleviate inflammation or stress in humans. As Carl Sagan famously stated in his 1980 series Cosmos, we are made of star stuff. GRB 230307A is estimated to have lasted for 200 seconds and approximately 1,000 times brighter than traditional GRBs. It was first detected by NASA's Fermi Gamma-Ray Space Telescope in March 2023, and astronomers used JWST's mid-infrared, mid-IR, imaging and spectroscopy instruments to conduct follow-up observations 29 and 61 days after the burst occurred. As noted, GRB 230307A is the second brightest GRB ever detected, with the brightest ever being detected in 2022 and was quickly called the boat to brightest of all time. GRB observations date back more than 50 years, with the first ever GRB being detected on July 2, 1967, and confirmation of the event coming in 1969. GRBs are classified as short and long, with short GRBs lasting less than 2 seconds and long GRBs lasting for several minutes. This burst is way into the long category. It's not near the border. But it seems to be coming from a merging neutron star, said Dr. Eric Burns, who is an assistant professor of physics and astronomy at Louisiana State University, a member of the Fermi team, and a co-author on the study. Kilonovas are the result of the merging of two neutron stars and have been hypothesized to produce elements that are both rare and considerably heavier than the element iron. However, much like the rare elements they allegedly produce, kilonovas are also incredibly rare and difficult to detect, which makes this infrared detection by JWST even more exciting. ESA and the Japanese Aerospace Exploration Agency are gearing up for a momentous milestone in Earth observation as launch of the EarthCare satellite approaches. Following years of rigorous development and extensive testing, the satellite is now undergoing its final round of tests in Europe before being shipped to the launch site early next year, bringing us one step closer to gaining unprecedented insights into the role that clouds and aerosols play in the climate system. With global climate change increasingly affecting our planet, EarthCRE's advanced instruments and technology are poised to provide invaluable data for climate research, improve the accuracy of climate models, and support numerical weather prediction. Specifically, EarthCare, which is short for the Earth Cloud Aerosol and Radiation Explorer, will answer some critical scientific questions related to the role that clouds and aerosols play in both reflecting incident solar radiation back out to space and trapping infrared radiation emitted from Earth's surface. This delicate balance is an important factor in regulating Earth's climate. Although it is known that clouds play an extremely important role in atmospheric heating and cooling, they remain one of the biggest uncertainties in our understanding of how the atmosphere drives the climate system. Earth's ARE's unique set of 4 instruments will provide a holistic view of the interplay between clouds, aerosols, and radiation. Its cloud profiling radar will provide information on the vertical structure and internal dynamics of clouds. Its atmospheric LiDAR will provide cloud top information and profiles of thin clouds and aerosols. Its multispectral imager will provide a wide scene overview in multiple wavelengths. And its broadband radiometer will measure reflected solar radiation and outgoing infrared radiation. The fact that these different measurements are all taken at the same time allows scientists to better understand Earth's radiation balance. Now back to you, Tim.
Thanks for those great stories, Hallie. Now, something I'd quickly like to mention. The director Nathaniel Kahn has brought the James Webb Space Telescope to IMAX with a movie called Deep Sky. There is this kind of power the images have. It really isn't from us. We're creating the context in which you can appreciate them, but we're not forcing it, the director said. And from a purely personal point of view, it is an absolutely amazing movie, and I would encourage everybody to go and see it when it's available in your area. Now, Hallie, have you got a terrible joke for us this week?
Why did the physicist go to the beach? Because he wanted to work on his tangent. Why did the biologist install a knocker on their lab door? Because they wanted to win a Nobel Prize.
As usual, Hallie, they are terrible jokes. Thanks everybody for listening this week. See you all next week. Bye for now.
The Astronomy Daily Podcast.
For the ones who get it done, the most important part is the one you need now. And the best partner is the one who can deliver. That's why millions of maintenance and repair pros trust Grainger. Because we have professional-grade supplies for every industry, even hard-to-find products. And we have same-day pickup and next-day delivery on most orders. But most importantly, we have an unwavering commitment to help keep you up and running. Call, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
Pro football player Travis Kelce is pressed for time during the football season. So he does 2 things at once. Whether it's grilling while mowing,
2 things at once!
or getting this season's updated COVID-19 shot at the same visit as his flu shot.
2 things at once.
You can be like Travis and ask your pharmacist about getting this season's COVID-19 shot at the same visit as your flu shot, if you're due for both, as recommended by the CDC. Learn more and schedule at vaxassist.com. Sponsored by Pfizer.